Dear friends, good morning. Today we can learn about selection of appropriate statistical tests. Okay, so this is a scenario. Dependent variable is categorical and independent variable is also categorical. Example of dependent variable is diabetes status, like diabetic or non-diabetic, anemic status such as anemic and normal. So dependent variable is categorical. Independent variables examples are obesity, obese, overweight, normal or underweight. Household income, low, medium or high. Education status, uneducated, primary school educated, secondary school educated, college educated. So categorical variable. Independent variable is categorical. So in that case, we can apply Pearson chi-square test. So both dependent variable and independent variable are categorical. Association between a categorical independent variable and a categorical dependent variable can be studied using Pearson chi-square test. We can move to next scenario. Okay, dependent variable is continuous. Okay, dependent variable is continuous variable such as height, weight, body mass index, glomerular filtration rate, serum cholesterol, fasting blood glucose, etc. And the data is normally distributed also. And the independent variable is categorical with two categories, two independent categories. It can be gender, obesity status, diabetes status, or hypertensive status. Gender is having two independent categories, male or female. Obesity status is having two independent variable, obese or non-obese. Diabetes status, diabetic or non-diabetic. Okay. If two independent categories are there and a dependent variable is continuous, in that case, how the scenario will be comparing the means of dependent variable between two independent categories. In that case, we can apply independent sample t-test. Okay. Now, another scenario. Dependent variable is continuous. As before, can be height, weight, BMI, glomerular filtration rate, serum cholesterol, or fasting blood glucose. And the data is normally distributed also. Okay. Independent variable is categorical variable with two related categories. Before and after treatment. Before and after an experiment in the same group of patients in two different time points. Okay, so scenario will be comparing means of continuous variable between two related groups or two related samples. Another situation is pre and post test. If you are doing an intervention, before the intervention, what are the values of hemoglobin? After the intervention, what are the values of hemoglobin? Then you are comparing the mean of hemoglobin values before and after the intervention. And the data is normally distributed also. In that case, you can apply paired samples t-test. Okay, we can move to next scenario. Dependent variable is continuous variable, same as before, height, weight, BMI, GFR, serum cholesterol, etc. Data is normally distributed also. Independent variable is categorical with more than two categories, more than two independent categories, like ethnicity. Ethnicity can be Malays, Chinese, Indian, others. Education status can have multiple categories, more than two categories. Uneducated, primary school educated, secondary school educated, diploma, degree, postgraduate, like that. Occupation groups can be different occupation groups like manual laborer, office job, professionals, like that. So the scenario is that compare the mean of dependent variable between more than two independent categories. In that case, you can apply one-way ANOVA test. Next scenario, dependent variable is continuous variable such as height, weight, BMI, GFR, etc. But data is not normally distributed. Independent variable is categorical variable with two independent categories. So the scenario is compare the means of dependent variable between two independent categories when data is not normally distributed or when data is skewed, can be positively skewed or negatively skewed. Data is not normally distributed. In that case, you can apply Mann-Whitney U-test. Non-parametric test, Mann-Whitney U-test. It is an alternative of independent sample t-test. When data is not normally distributed, please go for non-parametric test. Here it is Mann-Whitney U-test, which is an alternative of independent sample t-test. Next scenario, dependent variable is continuous. Okay, like height, weight, BMI, GFR, serum cholesterol, fasting blood glucose, etc. Data is not normally distributed. And the independent variable is categorical variable with two related categories, like before and after treatment or before and after an experiment in the same group of patients. Okay, like the previous example for paired t-test, no? One group of patients before starting treatment, what is the hemoglobin value? After starting treatment, what is the hemoglobin value? We are comparing the hemoglobin value before and after. Or before the statistics class, what is the knowledge score? After the statistics class, what is the knowledge score? We are comparing before and after. But data is not normally distributed. So we cannot apply paired sample t-test here. We have to go for non-parametric alternative of paired sample t-test. That is Wilcoxon sign rank test. Non-parametric test, Wilcoxon sign rank test. It's an alternative of paired sample t-test. We can move to next scenario. Dependent variable is continuous variable as before and the data is not normally distributed. Independent variable is categorical variable with more than two independent categories like ethnicity, education status or occupation groups. The scenario is similar to one-way ANOVA, but the data is not normally distributed. Okay? Comparing means between more than two independent groups when data is not normally distributed or skewed. In this case, we can apply non-parametric alternative of one-way ANOVA test, that is Kruskal-Wallis test. Non-parametric test, Kruskal-Wallis test. It's an alternative of one-way ANOVA test. Okay. Now we can move to next scenario. Okay. Dependent variable or outcome variable is continuous or numerical variable such as fasting blood sugar values among one sample or one group. Data is normally distributed. What we are going to do, we are comparing the mean fasting blood sugar value of one group of people with a standard value obtained from guidelines. You can obtain the standard value from standard textbooks or clinical practice guidelines or World Health Organization guideline. Okay. Check if mean fasting blood sugar value is significantly different from the standard value or test value. In that case, you can apply one sample t-test. Because data is normally distributed, so we have to choose parametric test. Parametric test here is one sample t-test. If data is not normally distributed, no, you have to choose Wilcoxon sign rank test for one sample. Okay, that is a non-parametric alternative of one sample t-test. Next scenario, dependent variable or outcome variable is continuous variable. Okay, like fasting blood sugar values. Data is normally distributed. Okay, please note that. Independent variable or predictor variable is categorical variable with two categories. Before treatment values or after treatment values. Okay. Among same group of individual at two different points in time. Compare means of two categories like before and after treatment. Check if difference in means in fasting blood sugar before treatment and after treatment is statistically significant. So in that case, data is normally distributed. So we can go for paired sample t-test. Now we can go through the next scenario. Dependent variable is continuous variable or numerical variable. Example, fasting blood sugar values, and the data is normally distributed. Okay. Independent variable is categorical variable with two independent groups. Okay. Like gender, male and female. Groups are independent or unrelated. So compare means of two independent groups. Mean value of fasting blood sugar in two independent groups. Check if difference in means in fasting blood sugar is statistically significant. Choose independent sample t-test. Next scenario, dependent variable is continuous variable or numerical variable like fasting blood sugar values, and the data is normally distributed. And the independent variable or predictor variable is categorical variable with more than two categories like primary educated, secondary educated, college educated, like that. Our aim is to compare means of uh, dependent variable in more than two categories. Check if difference in means in fasting blood sugar in different education groups is statistically significant. We can apply one-way ANOVA test because data is normally distributed, right? So we have to choose parametric test, and number of independent groups are more than two. So we have to choose one-way ANOVA test. Okay, let us go to next scenario. Dependent variable is continuous variable and the data is normally distributed. Example given in this is systolic blood pressure values. And the independent variable or predictor variable is continuous variable or numerical variable. Body mass index values. That is also normally distributed. So dependent variable is also continuous variable. Independent variable is also continuous variable. What we are checking, is there any linear relationship between dependent variable and independent variable? Is there any linear relationship between body mass index and systolic blood pressure? Okay, we all know that as body mass index increases, systolic blood pressure increases. So there is a linear relationship, right? How to study if there is linear relationship between independent variable and dependent variable, if there is a positive linear relationship or negative linear relationship, we can apply correlation test. Because data is normally distributed, no, you have to apply parametric correlation test. That is Pearson correlation test. Okay. Pearson correlation test will help us to know if there is a linear relationship between independent variable and dependent variable. And one more thing, if the linear relationship is statistically significant or not. Now we can go through the next scenario. Dependent variable or outcome variable is continuous variable or numerical variable. Okay, like systolic blood pressure value is the dependent variable. Independent variable is also continuous variable or numerical variable like body mass index. Both are normally distributed. What is our aim, to predict the value of continuous dependent variable based on the value of continuous independent variable. So if you are getting the value of independent variable, can you predict the value of dependent variable? Body mass index is 25. What is the value? What may be the value of systolic blood pressure of the person with a body mass index 25? So we are predicting the value of dependent variable based on the value of independent variable. Okay, requirement. There is a linear relationship between independent and dependent variables, and both variables are normally distributed. So in that case, you can apply linear regression analysis to predict the value of dependent variable from the value of independent variable. Choose simple linear regression analysis. Simple linear regression analysis means it predicts the value of one dependent variable based on the value of one independent variable. Multiple linear regression analysis means multiple independent variables are there. It predicts the value of one dependent variable based on the values of multiple independent variables. That will be multiple linear regression analysis. Simple linear regression analysis means predict the value of one dependent variable based on the value of one independent variable. Next scenario, dependent variable is categorical variable, like presence of lung disease, yes or no. Independent variable is also categorical, exposure to tobacco smoking, smoker or non-smoker. Both are categorical variable. Dependent variable is also categorical, independent variable is also categorical. So what we are going to do, association between two categorical variable with any number of categories. Okay, can be more than two categories also. Okay, association between two categorical variables can be studied using this test. Check if the proportion of lung disease among smokers is significantly different from proportion of lung disease among non-smokers. Okay, among smokers, 80% got lung disease. Among non-smokers, only 30% got lung disease. So we are checking if the proportion of lung disease among smokers is significantly different from proportion of lung disease among non-smokers. In this scenario, we can apply chi-square test. That is Pearson chi-square test. Okay. Now next scenario. Okay. Dependent variable or outcome variable is continuous variable, like body mass index values. Okay. And the data is not normally distributed. Okay. Independent variable is categorical with two categories, like before treatment and after treatment. among the same group of individuals. So we are comparing body mass index values among a group of patients before treatment and body mass index value among the same group of patients after treatment. We are comparing if there is any difference, and the data is not normally distributed. So when data is not normally distributed, we cannot apply paired t-test, right? Because data is not normally distributed. Then we have to look for the non-parametric alternative of paired t-test, that is Wilcoxon sign rank test. Choose non-parametric test for related samples, that is Wilcoxon sign rank test for related samples, alternative to paired samples t-test. What is the aim? Compare numerical data before and after treatment when data is not normally distributed. Check if difference in body mass index value before treatment and after treatment is statistically significant when data is not normally distributed. So which test? Wilcoxon sign rank test for related samples. That is a non-parametric alternative to paired t-test. Next scenario, dependent variable is continuous or numerical variable such as body mass index values and the data is not normally distributed. Independent variable or predictor variable is categorical variable with two groups or two categories like gender, male and female. They are independent categories, right? Compare numerical variable of two unrelated groups. Check if difference in BMI values in two independent or unrelated groups is statistically significant. Data is not normally distributed, so we cannot apply independent sample t-test. We have to look for non-parametric alternative of independent sample t-test, that is Mann-Whitney U-test. Choose non-parametric test for unrelated or independent samples. Mann-Whitney U-test. It is alternative to independent sample t-test. Next scenario. Okay, dependent variable is continuous variable such as body mass index. Data is not normally distributed. And independent variable is categorical variable with more than two categories like primary educated, secondary educated, college educated, like that. More than two categories are there. Compare numerical data with among more than two independent categories. Check if difference in body mass index values in different education groups is statistically significant. We cannot apply one-way ANOVA test here because data is not normally distributed. So we have to look for non-parametric alternative of one-way ANOVA test, that is Kruskal-Wallis test. Choose non-parametric alternative test of one-way ANOVA test, that is Kruskal-Wallis test. The last scenario, dependent variable is continuous variable or numerical variable such as fasting blood sugar, and the data is not normally distributed. And independent variable is continuous variable or numerical variable like body mass index, and the data is not normally distributed there also. So to study the linear relationship between independent variable, that is body mass index, and dependent variable, that is fasting blood sugar, if there is a positive linear relationship or negative linear relationship between body mass index and the fasting blood sugar, we cannot apply Pearson correlation test here because data is not normally distributed. So we have to look for non-parametric alternative of Pearson correlation test, that is Spearman correlation test. Choose non-parametric correlation test, that is Spearman correlation test. Hope you understood. Thank you very much.